This video is about solving quadratic equations. Now we have three equations to solve with different format. So the first one in part A is x minus 1 multiplied by x plus 8 equal to 0. Now this is the easiest form to solve because it's already factored with the right side equal to 0. Now if I say that I have two numbers a multiplied b equal to 0, it means that a equal to 0 or b equal to 0. And this is the idea we're going to apply here. Let's assume that this is a and this is b. So it's either a equal to 0 or b equal to 0. And then you solve these equations that are linear equations and very simple to solve. And the second solution is when you solve this equation here, it gives you x equal negative 8. So this is very straightforward, very simple to solve. Remember, you need to have 0 on one side, either to the right or to the left side, as long as the expression is equal to 0. Now, the equation in part B has the left side in factorial form, but the right side is not equal to 0. So we cannot use the idea we have used in part A. Good. Now let's try to expand. So we distribute the x by x that gives me x2, and then x by negative 1 that gives me minus x, and then equal to 1. Now let's write the equation in standard form, meaning that everything on one side and 0 on the other side. Now we can do this here by subtracting 1 from both sides. I have subtracted 1 from both sides. Why? Because I want this one to become 0. Now I simplify. And when this side is equal to 0, we say the equation is in standard form. Now trying to factor this, it doesn't seem to go easily, to be factored easily. So let's try to use another way to solve the quadratic equations, which is the quadratic formulas. Let's review them here before we use them. Quadratic formulas. Now the quadratic formulas, when you have got an ax2 plus bx plus c, this is your equation. You go and you find the delta. Yeah, the discriminant, it's b squared minus 4ac. Good. So let's go here to our equation and find a. A is equal to 1. Yeah. A is the coefficient of x2. B is the coefficient of x. B is the coefficient of x here. What is the coefficient of x? Negative 1. C, what is C? C is the constant term. It has no x with it. So it's C equal negative 1. Now let's continue. So let's find our discriminant. Delta equal b squared minus 4ac equal b is equal to negative 1 squared minus 4a equal to 1 and c equal negative 1. When we simplify all this, it's going to give me 5. Now let's go here and put the formula of the solutions. Quadratic formula. It's given by minus b, negative b, plus or minus the square root of the delta, the discriminant, divided by 2a. So let's go here and apply it. X, 1, 2, two solutions, remember. Minus b equal to minus 1, minus 1, 1, plus or minus the square root of 5, divided by 2a, a is equal to 1. Simplify this, and we are going to have 1 plus square root of 5 over 2. This is the first solution. The second solution, 1 minus square root of 5 divided by 2. Now we solve the equation in part C, which is 2x2 plus 6x equal to 8. Now when we look at the coefficient and the constant here, they are all even numbers. Therefore, before we start solving, what we can do is to divide all terms by 2. So 2x2 plus 6x equal to 8 divided by 2 here, by 2 here, and by 2 here, everywhere, all the terms. So 2 by 2 gives me 1. 1x2 is x2 plus 6 divided by 2, 3. 3 times x, 3x. And then equal to 4 here. So that has simplified the coefficient. The numbers are becoming smaller. And we can easily see how to solve this. Now let's write it in standard form. By subtracting 4 on each side. Yeah, we have 4 here. So minus 4 will give me 0, but I need to do the same thing. Minus 4, minus 4. Now we simplify, and that's going to be x2 plus 3x minus 4 equal to 0. So the equation now is in standard form, and we can solve it by any method. Now let's try factoring here. Factoring seems to be okay. So it's going to be x here and x here, and then we need two numbers. Let's call them m and k, for example. So we need to find m and k so that this equation is equivalent to this one. Now, if I expand here, now these numbers, when I multiply them, m multiplied by k, they will have to give me the constant term, minus 4. And then when I add them, m plus k, they will have to give me the coefficient. Now there is something wrong here. This is 3x. So they need to give me the coefficient of x, which is a 3. So what are the two numbers that multiply into minus 4 and add to 3? Let's see. I have 1 and 4, which is either negative 1 and 4. When you multiply them, they give you minus 4, or 1 and minus 4. I have other options, of course. I have the 2 and the 2, so negative 2 by 2. Now, very clearly, if I add these two numbers, the negative 1 and the 4, they give me 3. If I add these two, they give me negative 3. Now, these ones here, if I add them, they will give me either 0. Yeah, they will give me 0 if I add them. So, this is out, and this is out, and this is one possibility. So, let's try it. Let's put the numbers and see. So, my equation becomes x plus, so let's call this m, and this k, it doesn't matter. So x minus 1, and then kx plus 4 equal to 0. Now let's check. x2. X by 4 plus 4x. Now minus 1 by x minus x. Minus 1 by 4 give me minus 4 equal to 0. And this is exactly the equation we have. x2 plus 3x minus 4 equal to 0, which is our equation here. Good. So in factored form, x minus 1, x plus 4 equal to 0. This is our equation in factored form. And now it's easy to solve, as we said above in part A. If I have two numbers and then I multiply them, they give me 0. It means at least one of them is equal to 0. Okay, again, it's important to remember that this side must be 0. One side must be 0. So either A equal to 0, that gives me the solution x equal to 1, or B, which is x plus 4, equal to 0, and that gives me x equal to negative 4. So two solutions again. Now, what to retain from this video is that always examine closely the equation given to you, whether it's factored, whether it's in standard form, whether the coefficient can be simplified as we did in part C, and so on. So always examine and think before you start solving. Sometimes the solution is very simple.